Okay, so let's talk about like a VQ mismatch. So in order to understand like a VQ mismatch that creates like a defect, it's important to understand um, normally what's going on in the lung. Okay, so here we have a lung, we have zone 1, which is near the apex, we have zone 2, which is near the middle of the lung, and we have zone 3, which is the base of the lung. Now, in the lung, these aren't, defined zones. They're not anatomical zones, they're physiological zones, and the size of the zones can vary depending on the condition. Okay, so to start out with zone 1, well, let's compare zone 1 with zone 3. Now, zone 3, because of gravity, okay, so gravity is going to cause the hydrostatic pressure in the capillaries in the base of the lung to be higher than the hydrostatic pressure in the capillaries of the apex of the lung. Okay, an increase in hydrostatic pressure is actually going to dilate those capillaries and allow for more blood flow or more perfusion through the base of the lung. Okay? Now, the base of the lung is also going to have more ventilation than the apex of the lung. Okay? Now, this is something that a lot of people get confused on. The base has greater ventilation and perfusion. Okay? Now, this VQ is the ratio of ventilation to perfusion. Okay? So in the base of the lung, the ventilation and perfusion ratio, or the VQ, is close to 1. Okay? Or 0.8. Now, near the apex of the lung, under normal conditions, this VQ is equal to 3. Okay? Meaning the difference between perfusion, between the apex and the base, is greater than the difference between ventilation of the apex and the base. Okay? So even though the base has more ventilation and perfusion, the difference between the apex and the base is greater for perfusion. Okay? And that's why the VQ, and if we just look at this as a fraction, okay, the V is going to be greater than the Q. And that's why we have a VQ greater than 1. Okay, and this is just an excerpt from first aid. Okay, so the apex of the lung, let's say it's about 3. At the base of the lung, let's say it's about 0.6. Okay, so the apex of the lung, you're going to have actually a higher concentration of oxygen, okay, than at the base of the lung. And right here is going to be too much ventilation, so it's going to be wasted ventilation. And down here, there's going to be too much perfusion, so it's going to be wasted perfusion. And remember, in an ideal situation, this VQ would be 1, meaning we'd have ventilation to match the blood flow.